Hello, and welcome to this lesson of our C Programming Foundations tutorial series. I'm Reza, and I'm happy to have you join me on this journey to mastering the C programming language. Let's move on to decision-making statements in C. Alright, let's talk about if statements in C programming. Kind of like making a decision in your code. Imagine it as a crossroad where you have to decide which way to go. First, you have a condition. It's like a question that can only be answered with a yes, true or no, false. If the answer is yes, meaning the condition is true, then your program will go down one path and execute the code that's wrapped up in curly braces right after the if statement. But what if the answer is no? If the condition is false and you've provided an else part, your program will run the code that's inside this else block. Think of it as the alternate route. And hey, sometimes you don't need an alternate route, so this else part is totally optional. So basically, an if statement is how your program makes choices based on whether something is true or not. Okay, so this piece of C code is pretty straightforward. It's all about making a decision based on a number. First, we've got this number x and we set it to 10. Then the code checks if x is more than 0. Since x is 10, which is definitely more than 0, the code goes like, alright, let's tell everyone that x is greater than 0, and it prints out exactly that. But if x was not more than 0, it would go the other way and say, hey, x is not greater than 0. It's like a simple road sign directing you to one message or another based on what x is. Alright, so think of the if-else if statement in C as a more advanced version of the basic if-else deal. It's like a series of checkpoints. Here's how it rolls. First off, your code comes across the if statement. It's like the first checkpoint. The code checks if the condition here is true. If it is, bam! It runs the code inside this if block and skips all the other checkpoints. But say the first condition isn't true. No sweat. The code then hops over to the else if part, which is like the second checkpoint. It checks out condition 2 here. If this one's true, then the code inside this block gets its turn in the spotlight. And that's pretty much the rhythm. The code keeps moving down this line of else if checkpoints. It keeps checking each condition one by one. If it finds a true one, it runs the code in that block and skips any remaining checks. But here's the twist. If none of those conditions are true, the code lands in the final else block. It's like the last resort where the code does something else if all the previous conditions were a no-go. We previously wrote a program to calculate BMI. In this video, we will create a basic C program to compute BMI and then determine the health status based on the calculated BMI. Before diving into the code, let's first review what BMI is. BMI stands for Body Mass Index. It is a numerical measure of a person's body weight relative to their height. BMI is widely used as a simple and quick screening tool to identify potential weight problems in adults. The formula for BMI is calculated by dividing a person's weight in kilograms by the square of their height in meters. The result is then interpreted using standard ranges to categorize individuals into different BMI categories. Underweight, BMI less than 18.5. Normal weight, BMI between 18.5 and 24.9. Overweight, BMI between 25 and 29.9. Obesity, BMI 30 or greater. Now, let's proceed to write the program and implement these calculations. Alright, let's talk about this cool little C program that's all about figuring out someone's BMI or body mass index. It's like a three-step process. 1. First off, the program's gonna ask you to punch in your weight and height. Weight in kilograms and height in meters. Just the basic stuff you'd hop on a scale or stand against a measuring tape for. 2. Next up, it takes those numbers and does some quick math to calculate your BMI. That's all done using a special formula. Once it's got your BMI figured out, it shows you what it is. 3. And the last part, the program's got this way of sorting out your BMI into different categories. So it will tell you if you're underweight, just right, that's normal weight, or overweight. It's pretty handy to see where you stand, health-wise, and that's pretty much what this program's all about. Alright, so let's break down the decision-making part of the BMI calculator code. It's all about figuring out where your BMI fits on the scale, underweight, just right, or overweight. 1. First up, the code hits you with an if statement. It's checking if your BMI is less than 18.5. If that's a yes, it means your BMI is on the low side and you're underweight. The code will then go ahead and print out you are underweight. 2. Then, if that first check doesn't pass, like your BMI is not less than 18.5, the code moves on to an else if statement. This one's a bit more specific. It checks if your BMI is between 18.5 and 25.0. If you land in this range, you're in the normal weight zone. So the code gives you a thumbs up with a message saying you have a normal weight. 3. Lastly, if your BMI doesn't fit into either of those first two categories, the code's got a final say in the matter with an else statement. It means your BMI is over 25.0. The code acknowledges this by printing out you are overweight. In this code, we skip determining the obesity category, but you can extend the code to include it as a practice. Alright, let's talk about how the switch statement works in C programming. It's like a multi-road junction where your code can take different paths based on the value of a variable. Here's the lowdown. 1. Starting the switch. You kick things off with the switch keyword followed by the variable you want to check. This variable is usually an int or char. 2. Setting up cases. Inside the switch block, you have different case labels. Each case corresponds to a possible value of the variable. 3. Executing code for a case. After each case label, you put the code that should run if the variable matches that case. It's like saying, if the variable is value 1, do this. 4. Breaking out. At the end of each case's code, you usually put a break statement. This tells the program to jump out of the switch block once it's done with that case. If you don't put a break, the program will just keep running into the next case, which can be useful sometimes. 5. The default case. After all your specific cases, you can put a default case. This is what the program does if none of the other cases match. It's like the else in an if-else chain. So, in practice, your code looks at the variable, jumps to the case that matches its current value, runs the code for that case, and then hops out of the switch statement. It's a neat and tidy way to handle a bunch of different scenarios based on one variable's value. Alright, so this bit of the code is like your personal day of the week guide. First, it asks you to punch in a number anywhere from 1 to 7, each number representing a day of the week. Once you've put in your number, it jumps into this switch statement thing. Here's where it gets cool. If you enter a number from 1 to 5, it's like telling you, hey, it's a weekday. But if you go for 6 or 7, it's all like, party time, it's the weekend. And just in case you enter something that's not between 1 and 7, it's like telling you, whoa buddy, stick to the script, pick a number from 1 to 7. It's a neat little program for figuring out what kind of day it is based on numbers, making it both useful and a bit fun. Here is a code challenge for you to get more practice. A simple calculator.